Hello chemistry students, in this video I'm going to go over neutralization reactions. Alright, so a neutralization reaction is a special type of double replacement reaction in which an acid and a base, under the Arrhenius definition, so we're talking about hydrogen ions and hydroxide ions reacting to produce water, and then the anion from the acid and the cation from the base will get together and make a salt. Let's see, the hydrogen ions from the acid and the hydroxide ions from the base are going to form water. So here's some examples. So some hydrochloric acid, which is an Arrhenius acid, and some sodium hydroxide, which is an Arrhenius base, get together, and the H and the OH get together and make water, and the sodium positive cation from the base gets together with the anion from the acid and makes sodium chloride, which is a salt. Here's another one, sulfuric acid and potassium hydroxide do something similar. So the hydrogen from the sulfuric acid and the hydroxide from the potassium hydroxide make water, and then the potassium, the cation from the base, and the sulfate, the anion from the acid get together and make potassium sulfate. And the two's coefficients are there simply to balance the equation. Alright, so you give it a try. So which acids and bases could be used to produce the following salts? So remember that the cation, the first element, the positively charged, usually a metal, will come from the base, and the anion will come from the acid. So pause the video, take a few minutes, see if you can figure these out. Alright, let's take a look at them. Okay, so the first one, the calcium chloride. So a base, basically you're putting hydroxide onto the calcium, and you're putting hydrogen onto the chlorine, or the chloride, and those would react. Underline the H and the OH here so you can see that those make water, and then the remainder of the calcium and the chlorine. Remember, you always write the more positive element first, so the cation would be written first and the anion would be written second to make CaCl2, and you know, the subscripts, you can get those from crossing the charges of these things. If you've forgotten how to do that, go back and take a look at Module 4. Alright, so the next one, the silver nitrate. So that could be formed if you had some silver hydroxide that reacted with nitric acid. So the cation forms the base with hydroxide, and the anion, nitrate, forms the acid with hydrogen, and you can see the H and the OH react to make water, and the remaining ions form the salt. And the last one, the sodium hydrogen carbonate. So sodium hydroxide could react with carbonic acid for that to happen, and the cation combined, the sodium combined with hydroxide, the anion, hydrogen carbonate, combined with hydrogen, an extra one, see that's HCO3, and that one's H2CO3, so it gained a hydrogen. So those can react, the H and the OH get together and would make a water. Alright, the term neutralization might suggest that the products will be neutral, but not always. Not always a pH of exactly 7 anyways. So some salts could produce either acidic or basic solutions, and it's going to be the nature of the salt is going to depend on the parent acid and base that produced it. So let's take a look at that. If a strong acid reacts with a strong base, remember we did a list of strong acids and strong bases in a previous video, you get a neutral salt, so that one's easy. So like hydrochloric acid and sodium hydroxide, that makes sodium chloride, so that's a neutral salt. However, if you have a strong acid and a weak base, like maybe you have hydrochloric acid and ammonium, then you're going to make ammonium chloride, which is a slightly acidic salt. Okay, if you have a weak acid react with a strong base, you're going to end up with a basic salt. And then if you have a combination of weak acid and weak base, well, it's kind of hard to tell whether it's going to be acidic or basic. It'd probably be pretty close to neutral, but it depends on the identity of the weak acid and the weak base. Basically, if the weak acid is stronger than the weak base, then you'll get an acidic salt, and if the weak base is stronger than the weak acid, then you'll get a basic salt. And to actually thoroughly answer that question, you need to use Ka and Kb values, which is an AP chemistry kind of topic. Alright, so in the next video we'll tackle titrations.